Welcome back, my dear students, to my channel Civil Knowledge. Okay, today let us continue our classes as we were doing some of the problems on basic properties of fluid. So we will continue our problem, some complex problem. Okay, yesterday or in the last session what we did was simple problems. Today somewhat complicated. It's not complicated, just we need to use some more formulas or we need to think deeply. Okay, so see, today's first problem and our unit's 8th problem. So calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size 0.8 meter into 0.8 meter, and it is inclined plane with an angle of inclination 30 degree as shown. So this is the figure. The weight of the square plate is 300 Newton and it slides down the inclined plane with a uniform velocity of 0.3 meter per second. The thickness of the oil film is 1.5 mm. So the square plate they are talking about, so this is the square plate. So between the square plate and the surface there is a oil film and the thickness is 1.5 mm. So, and the weight of the square plate is 300 Newton. So weight is always acting towards gravity. Then what's given? So inclination is 30 degree, fine, and it slides down with a uniform velocity of 0.3 meter per second. Okay, then what we need to find? We need to find the dynamic viscosity of an oil. So I'll write down the solution now. First, what we will note down the given. What are the given things? So if you write down the given things, we could estimate what formulas we can use in this problem. So given, what is given? Area of the plate. Area of plate, how much? 0.8 into 0.8. Okay, so I'll calculate it. That is 8 is a 64. So 0.64 meter square is the area. Then angle of the plane. So angle of plane is nothing but what? Inclination is given as, I'll take it as theta, that is 30 degree. Okay, first this. Second, next what? Weight. Weight of plate, how much? 300 Newton. Okay, next velocity. So velocity is given as, I'll denote it as u, and it is 0.3 meter per second. So these are the given things, and also the thickness of the plate. So thickness, small t. Okay, and it can also be called as what? Thickness means they are defining a thickness. They are giving thickness means what? They are basically giving the distance of the plate. Okay, the thickness of the plate from this to this, how much is the distance? So it is nothing but some type of length, right? So I'll take as dy. So du I can find out from this if in case I required. So I'll take thickness as what? Dy 1.5 mm. Okay, this thickness is of the oil film. Okay, so here given the thickness of the oil film is 1.5 mm. So here the distance is 1.5 mm. So I'll take that as dy athwa t. So now what we need to do? What we need to find? We need to calculate the dynamic viscosity. So we don't know the dynamic viscosity. Let us assume. Okay, let us assume means what we are taken. No, we will write that like, let the viscosity viscosity of fluid, okay, between plate and inclined plane. Let the viscosity of fluid between the plate and the inclined plane is, from what we will define, is mu. Let that be mu, and we need to find the mu. Okay, now see here, this is 300 Newton. Okay, so u is the velocity. So in your first year you have learnt when the velocity is like this, okay, some of the force will be there. Okay, it's also called as what? If velocity is sliding this way, the friction force will be opposite to the velocity of plate. So friction force exerts a force like this, opposite to the running force, right? Now we need to find a force. Okay, that may be here in this chapter, where if any force on the liquid is what? Shear force only. So we need to find this force. So how to get this force? So this force is related to, so here see, W 300 Newton. So this is W is acting 300 Newton. When I resolve this W force, okay, so one of the component will be along the plane. The component along the plane will be what? This is 30 degree. So 90 minus 30 is 60 degree. Okay, so the component which is opposite, if I take this friction, so just I inputted this concept, that's it. Okay, so the component of this weight, it is 300 Newton, and its component, if we resolve, we will get like this. Okay, so we know that this is 30 degree, this is also 30 degree, so 90 minus 30 is 60 degree. So this force I want, so what I can write? 60 degree, okay, with respect to the plane is 60 degree, right? So I'll take this as W cos theta, and this one W sin theta. So what I want? I want this force, because I need to find the force at the bottom surface of the plate, where oil is there. Fine. Now what I want? I want to find this force. I want what? Component of weight along plane. What is that? It is nothing but W cos 60 degree. So component along the plate is W cos 60 degree. So what is the W cos 60 degree? What is W? W is nothing but 300 Newton. So 300 cos 60 degree. Cos 60 is what? 0.5. So 0.5 into 300 is 150 Newton. So this is 150 Newton is nothing but your force. Okay. So I'll write a comment that shear force on bottom of plate is what? 150 Newton. Okay. Now what we need to find? We need to find mu. And what the formulas we are knowing? I know one formula, that is with regarding to this chapter, that is shear stress is equal to mu into du by dy. Okay, I need to find this. I don't know this, I know this. Okay, so this formula we are not getting, but when I go to the definition of shear stress, so what is the definition of shear stress? Shear stress definition, what is that? Force by area. Tau is equal to what? Force by area. Okay, this insight should come to your mind whenever area is given. So area nu kottidane, force kottidane andmele he is indirectly giving you what? The shear stress. So What will be the force? Force is 150 Newton divided by area is to 0.64. So that will be so your 150 divided by 0.64. So your shear stress directly you can take either you can take 234.375 or you can keep it like this only 234.375 because it is not the ultimate value, right? Okay, so Newton per meter square. Either you keep this or whenever you need to substitute for tau you can directly substitute this 150 by 0.64. Okay, now I got the value of shear stress. Now what formula I have? I have this formula. So I'll directly write that tau is equal to mu into du by dy. So I know this. So tau is what? I'll take this fraction unit without simplifying. Okay. So what is du? Du was change in velocity. Okay, dy is the thickness, mu I need to find. So change in velocity means what is that? U minus 0. I don't know the final velocity where it gets stopped. So I'll take u as du only because change of velocity is I don't know. That's why it is not given. So I'll take du as 0.3 meter per second. So I'll substitute now for tau. That is what? 150 divided by 0.64 is equal to, I need the value of mu, I know du, the change in velocity, so I know I have only one velocity, I'll rewrite that. So dy is what? 1.5 into 10 power minus 3. Why? It is in mm. So 1.5 into 10 power minus 3 meter. So everything is meter. When you take, it should be, everything should be in meter only. Then the value of mu will be, after simplifying, so this is already we simplified, that is 234.375 into 1.5 into 10 power minus 3 divided by 0.3, it is 1.17. okay, so the value of mu is 1.17. What is the unit of mu? Newton second per meter square. If suppose in some of the questions they will ask purposely, they will ask to give the value of mu in, what is the other unit, as I discussed in the last class, poise. So if they ask poise, then it would be 11.7 poise. Now don't ask how, because I already discussed with you. Okay, or else see here 1.17 into 10, if we do multiply by 10 we will getting 11.7 poise, because 1 poise is equal to 1 by 10 Newton second per meter square. So this is the procedure how we do. Okay, so I have written another question also, the 9th one. So we will solve this problem also. See, first we will note down the given things what are given. So a square, I written as cube, sorry, a square of 0.25 meter having a mass of 28 kg. So a square of 0.25 meter having mass of 28 kg slides down a plane at 2 vertical and 3 horizontal. So here the inclination, the theta, the degree has not given, they have given in ratio form, that is 2 vertical and 3 horizontal, covered by a thin film of oil of viscosity 2.2 into 10 power minus 3. If the thickness of the film is 0.02 mm, find the steady state velocity of the block. So here they are asking what steady state velocity means. What u, or else you can find as it as du. We need to find steady state. We need to find du. Okay, so if I take diagram, it will be like this, same as previous only. So here we are getting the square. Okay, fine. So the weight will always act towards the gravity, that is what, 28 kg. Then what I have given, so area of a side 0.25 meter. Then they have given 2 vertical, so this is 2 and this is 3, 2 vertical to 3 horizontal, so theta. So how to find theta? Theta is nothing but tan inverse of opposite by adjacent, that is 2 by 3. So theta will be 33.69 degree. Okay, check in the calculator, you will get the same, that is 2 by 3. So tan inverse of 33.69. Now I will take what is given, weight is given as 28 kg. So because it is given in kg, I will convert it into Newton. Okay, how to convert Newton? I had already told you. So 28 into 9.81 will fetch us the value of kg in Newton, that is 274.68. 274.68, what is that? Newton, because our SI unit should be in Newton meters, for this meter per second. Okay, that's why we are converting the kg term in Newton. Then theta we got to know, that is 33.69 degree. Then velocity is given, right? Velocity, thickness of the film is given, velocity we have to find, right? Okay, oil of viscosity, viscosity is given, right? So viscosity, how much it is? 2.2 into 10 power minus 3 Pascal. Okay, direct they have given in Pascal. Fine, no problem. Pascal means what? Newton per meter square, both are same. Then what is given? Thickness of the film, it is what? dy athava t. How much it is? Thickness of the film is 0.02 mm. I can convert it into 0.02 into 10 power minus 3 meter. Okay, then as we did in the earlier, what we need to take? I need to take weight along the plane surface. So I need force. So component of weight along inclined plane, that is what? W cos, how much? 33.69 is given, right? Now what will happen here? See, if I take an parallel line to this, so this is theta, so the component will be, so this is what? W cos, this is 90 degree towards perpendicular, idike idu perpendicular irbekovatu, so it is W sin. So theta is what? 90 minus this thing, 33.69, that is 90 degree minus 33.69. So 90 minus 33 point, it is 56.31 degree. Okay, you can do this or you can take another method. What is that? I'll tell you 1 minute. So W cos 56.31 degree. So what is this W? This W is 274.68. So cos of answer is 0.554. So when I multiply with 274.68, I am getting the value of force is, what is that, 152.36 Newton. Another method which I told is, that is, so W cos 56.31. If I want to use this only, what I can do, simple mathematics, that is, I can calculate as the force as W sine whatever this angle is, that 33.69 degree. So what is sine 33.69? Same as that, 274.68. It is 152.36. So either you can follow the cos one or you can follow the sine one, but taking the degree is important. Whatever the inclination degree you want to take, directly take the sine function. If you want to take, if conceptually if you go, means you have to take cos. Okay, this is to not to confuse. Some will directly take as sine term. Okay, whatever the inclination is given, they will multiply with the sine term. Okay, so when I do the diagram and we will look like this, the concept, we should take W cos 56.31. So whatever may be the case, the answer should be 152.36 Newton. Okay, what is this? This is the force, right? This is some of the force. So what we know, shear stress is equal to force by area. So what is this force? 152.36. What is the area? Area of the square is what? A square. So what is A? One side is given as 0.25. So 0.25 square, 0.25 square. So the value of tau will be 152.36 divided by 0.25 square. It will be, the tau value will be 2437.76 Newton per meter square. Okay, so I got the value. What I need to find? I need to find du athwa u. So I have the formula, tau is equal to mu into du by dy. Okay, so what is the value of tau? That is 2437.76. What is the value of mu? It's already given, 2.2. So I'll write here 2.2. You also write along with me so that you can also complete. Okay, don't just see, just copy it. Okay, as I am telling, you also copy so that you will be perfect. So what is this? Mu 2.2 into 10 power minus 3 into du. What is dy? The thickness of the film is 0.02. 0.02 into 10 power minus 3. Okay, whenever I solve this, see, 2437.6 into 10 power minus 3 divided by, when I cross multiply, it should be divided by this only, no? 2.2 into 10 power minus 3. So the value of du will be, see here, 22.16. So what is the value of velocity? What is the unit of velocity? It is meter per second. So the value of du is 22.16 meter per second. So I can write u also 22.16 meter per second. So this is the steady state velocity. This is the steady state velocity of the block which is asked in the question. So now next we will go to the next problem. Okay, so I am going on every type of problems so that you should not have any difficulty. Okay, sometimes the problem on intensity, we need to find the intensity of the shear whenever, and some power concept has been given. Okay, some RPM, shaft, these are all some power concept, right? Power concept which you studied earlier in your PUC. Okay, some formulas will come, so remember that, and whenever they are required, put them, substitute, and you will find your answers. So next question here. Determine the intensity of the shear of an oil having viscosity. So they are giving already viscosity 1 poise. The oil is used for lubricating the clearance between a shaft of diameter 10 centimeter and its journal bearing. The clearance means what? The dy they are given, or it is the space between the shaft, okay, where the oil will be placed. The clearance is 1.5 mm and the shaft rotates at 150 rpm. So whenever they will give some of the terms in 150 rpm, so we should remember the formula of power. Okay, when we deal with the concept of power, we will get some of the formulas. Okay, so I'll let you know while doing the problem only. Okay, so first I will write the given concept, what are given. So dynamic viscosity is given, that is 1 poise. Okay, we need to find the intensity of the shear. Okay, intensity of shear means what? Tau. We need to find. Now, so 1 poise is there, muse, and viscosity. The oil is used for lubricating the clearance. Okay, next D I will take as 10 centimeter. 10 centimeter is nothing but the 0.1 meter. Okay, so this is 1 poise, right? So I will take it in 1 by 10 Newton second per meter square. So I'll use this value 1 by 10 Newton second per meter square. I will not use poise because I don't have that term. So I need SI unit system. Okay, Newton second per meter square. I follow SI unit system. So this is 0.1 meter. Okay, now what they are given? Another, the distance between, okay, the clearance, the shaft and journal bearing. So here distance between shaft and journal bearing, what I told, it will be dy, right? So dy is equal to 1.5 mm, or dy is equal to 1.5 into 10 power minus 3 meter. Okay, so dy is 10 centimeter, it's 0.1 meter. I converted, so I converted the distance between shaft and the journal bearing also, and the speed of the shaft they have given, speed. Okay, so remember this, speed of shaft which they have given, so I'll term it as n. So whatever the speed of the shaft they have given, it termed as n, and it is 150 rpm. So this rotation per minute, it is taken as rpm. So we have a formula to calculate velocity u whenever rpm is given with diameter. So what is that formula? Please remember that. So 1 minute, red pen. Okay, so the formula is, please remember this, u is equal to pi dn divided by 60. So whenever a speed of shaft or rotation per minute n term is given with diameter, the speed can be calculated by u is equal to pi dn by 60 degree. So I'll use that formula, u is equal to pi dn by 60. So what is the value of pi? It is nothing but, okay, so it is constant, it will come in your calci only. So pi into 0.1 into 150 divided by 60. Okay, I'll show you where the pi will comes. So you have to press this shift, and after that this exponential, then you will get the value of pi into 0.1 into 150 divided by 60, that is 0.785. So 0.785 meter per second. This is the value of u. Okay, so which formula we know? We know only one formula. What is that? That is tau is equal to mu into du by dy. Okay, so here also we don't know the initial and final velocity. Okay, so I'll take u as du only. Okay, now this poise is already given. The value is 1 by 10. Okay, so 1 by 10 into du what is the value of du? 0.785. Okay, dy value is what? 1.5. 1.5 into 10 power minus 3. So if we substitute, we are getting the value of pi, that is 0.785. 1.5 into 10 power minus 3 divided by, it is 52.33 Newton. 52.33 Newton per meter square. It is the value of what? Shear stress or intensity of the shear whenever the speed of the shaft, rotation per minute concept is given. Remember this formula. If this formula is not there, you can't solve the problem. So every type of problem I am covering, please refer it. Okay, another example I'll take. So 11th problem is the dynamic viscosity of an oil used for lubrication. So the dynamic viscosity of an oil used for lubrication between a shaft and sleeve is 6 poise. The shaft is of diameter 0.4 meter and rotates. See here, the shaft is diameter 0.4 and rotates at 190 rpm. So what formula you need to remember, that is u is equal to pi dn by 60. Calculate the power lost. So another formula will come here. Power lost in the bearing for a sleeve length of 90 mm. The thickness of the film is 1.5 mm. So it's difficult to imagine. See here, I'll take a shaft. Shaft means what? It's a pipe only. Okay, I'll take a shaft here. So this is the pipe. Okay, so the dynamic of oil used for the lubrication between the shaft. So okay, so this is the shaft and sleeve. This is what? Shaft, and this is what? Sleeve. It is the cutted image. Okay, this is shaft, pipe like structure, and upon that it is sleeve. This sleeve ante, how much is this sleeve? This is 90 mm. So in the calculate the power loss in the bearing for a sleeve length of, so for a sleeve length of 90 mm we need to calculate the power lost. Okay, and the thickness of the film. So whatever the thickness here, so the thickness of the film means the oil film thickness is what? 1.5 mm. It's given here. Okay, it is 1.5 mm. So what are the given values? We will see here. So what is given? The dynamic viscosity is given, that is mu is equal to 6 poise. So what I need to do? I need to convert it to the Newton second per meter square, right? So what it will be? 6 by 10 Newton second per meter square. So if I simplify more, it will be 0.6 Newton second per meter square. So for this problem, remember this 0.6 Newton second per meter square. So I'll take to the next page. So then what they have given means, so I think you just note down the question, okay, or take a screenshot and then note down. So I noted down the poise value. The shaft is of diameter, I need to note down the diameter 0.4 and it rotates at 190 rpm. N is 150, 190, diameter D is 0.4 meter and what 90 mm sleeve film is 1.5. Okay, so I'll directly write here. So dia of the shaft, dia of shaft, how much it is? 0.4 meter. Okay, D. Then speed of the shaft, speed of shaft, N is equal to 190 rpm. Then sleeve length, I'll take this as L, 90 mm. So for SI unit 10 power minus 3 meter. Next, what I have given? Thickness of the film, that I'll take it as dy अथवा T, 1.5 into 10 power minus 3 meter. Okay, I am having these values. So I told you to remember one of the formula to find what? To find the velocity. That is, we know that what we know? Nothing. That is, u is equal to pi dn by 60 degree. So whenever I solve, pi into d is 0.4 into n is 190 divided by 60, the value of u will be, so how to write pi? Shift ಹಿಡ್ಕೊಂಡು exponential ಒತ್ತಿದ್ರೆ pi type ಆಗುತ್ತೆ, into 0.4 into 190 divided by 60, it is 3.98 meter per second. Okay, done. Now what I need to find? I need to find what? Shear force. So what formula I know? So tau is equal to mu into, oh, power is gone, my dear friends, wait. So sorry for the disturbance, my dear friends. So power has gone, so it is the flashlight of the mobile, so I think it's visible, right? So tau is equal to u into du by dy. Okay, now what I know? Du, so it is what? Change in velocity. So u minus, I don't have another value, so I'll take it as 0. So u minus 0 is nothing but what they have given is, means what we calculated, 3.98 meter per second. I'll take du as u only. So dy, what I'll take? 1.5 into 10 power minus 3 meter. So the value of tau is equal to 10, this mu value is 10 Newton second per meter square, correct? It is 6 by 10. Wait, I'll directly take the value as 0.6. So mu is 0.6 Newton second per meter square, right? Okay, so 0.6 into du, 3.98 divided by dy is 1.5 into 10 power minus 3. So the value of tau is 0.6 into 3.98 divided by 1.5 into 10 power minus 3. This value will be 1592 Newton per meter square. Okay, 1.592 Newton per meter square. But we found the shear stress. But here in the question, what we need to find? We need to find the power lost. Okay, here another formula will be there for the power lost, so please remember that. So this is the shear stress. So tau, which we found, it is what? It is the shear stress. Okay, shear stress on shaft. Now what we need to find? We need to find the shear force on the shaft. Okay, stress is different, force by area. Now we need to find what is stress? This tau, force by area. Now what we want? I need force. What I do? I'll send this area to that is tau into area. Okay. Now what I want? Shear force. Why do I need to calculate the force? Because that force will help me to find out the torque. Okay, and with that torque I can find the power lost. Okay, so the series of formulas are there. So these formulas are independent, they are dependent. Okay, I need force here. Before that I'll tell you one thing. See, so from this I'll calculate the force. After calculating force, I need to find the torque. Why? Because I know the value of, so power lost formula is 2 pi nt by 60 degree. It's not 60 degree, it's just a value, empirical formula. So 2 pi nt by 60, where n is I know, this t is nothing but the torque. 2 pi nt by 60 is nothing but the power lost. So power is back, my dear friends. So wait, I need to align. Okay, now shear force, right? So it is the shear stress. I need to find the shear force. Okay, and I know the diameter of the shaft is given, means the diameter should be, that the cross section of the pipe is what? Circular, right? Now I need to find the shear force. So force is equal to shear stress into area. Now what is the shear stress? 1592 into area is what? I can find this area because it is a pipe length, right? So pi d into L. If I do this, I'll get the length of this shaft. So its cross section is pi d. How much length? Length I have to do. Length is as the length of the sleeve only. Okay, sleeve ಎಷ್ಟು ಲೆಂತ್ ಇರುತ್ತೋ ಅಷ್ಟು ಲೆಂತ್ ಪೈಪ್ ಇಂದ ಮಾತ್ರ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ನಮಗಿರೋ ಡೇಟಾ ಅದಷ್ಟೇ. ಫೈನ್. ಸೊ ಏರಿಯಾ ಇಸ್ ವಾಟ್? pi into d into L is the area. So 1592 into, so area is pi d. So pi into, what is the diameter? It is 0.4. What length? 90 into 10 power minus 3. So when I calculate it, I'll get around 1592 into pi into 0.4 into 10 power minus 3. It is 1805 Newton. So it is force, right? So force will be in Newton. So now what I want? I got the value of force. Why I need to calculate the value of force? Because I need to find the value of torque. So torque on the shaft. These all formulas you have already learnt in your PUC. Okay, just refresh it. So torque is equal to what? Force into d by 2. So what is the force? 180.05. Diameter is what? 0.4 by 2. It will be, the torque value will be 36.01 Newton meter. Okay, so remember this, the torque is equal to force into distance. Half distance will tell you theoretically, but here directly remember the value of torque is force into d by 2. 180 into 0.4, that is 36.01. Now the main concept which the problem was framed to be, to find what? To find the power lost. So power lost I will calculate. That is nothing but what? 2 pi nt by 60. So 2 into pi into 190 into torque is 36.01 divided by 60. So when I solve this, so 2 into pi into 190 into 36.01 divided by 60, it is 716.48. So the power lost will be 716.48. So what is the unit of power? It is nothing but watt. So this is the power lost. In case in this concept, if they ask, means you should be ready to do this problem. What you need to remember, you just need to remember what some formulas, that is U is equal to pi dn by 60, one formula. Second is, you know, force is equal to shear stress into area. After that, why do you need to find the force? To calculate torque. Torque is nothing but force into d by 2. So once I get the torque, the power lost is 2 pi nt divided by 60. If you follow these 4 points, your answer is solved. Okay, theoretically you just simplify one by one, you will get the answer. Okay, so these were the 3 problems, 3, 1, 2. These are the 4 problems for this session. So the next problem will be taken in next session. Thank you, my dear friends, and sorry for the power interruption. Okay, our power was also lost during our session. Okay, thank you. Good day.